This work, I'm going to talk about conversational context for conversational AI is this central theme. And this is going to reflect examples from a bunch of different studies that I've been involved in, and that means a whole bunch of different collaborators, including Ellen and other students, as well as Tao Yu, Hannah Hajishirzi, and Noah Smith from the University of Washington. And a lot of this work has been funded by industry, and also there's some work, some results from the National Science Foundation. Okay, so I want to start with laying out the assumptions I'm bringing to this this problem. First of all, I like to build things that are useful. And I think conversational interactions are useful in learning, they're useful in problem solving, they're useful in relationship building. And so I'm coming from the perspective of I want my system to actually do something. And the second big assumption is that we can use these large pre-trained language models, as lots of you are already doing, and you've heard from Michelle, to do conversational AI. They're very powerful, but I'm going to argue that the input to them matters. Okay, so what do I mean by these pre-trained language models? So basically, we're reframing this sequence to sequence model problem. So sequence in the user utterance goes to sequence out the dialogue system response. We're going to reframe that as a single autoregressive language model. So rather than encoder decoder, it's one big language model where the input is really a prefix to the language model. And then you're going to generate the output given that input, given that prefix. And this big language model can be pre-trained on many different tasks, so many different types of prefixes. So it by doing so, it actually learns that part of the language model's goal is to understand the task, not just what are the words, not just the topic and the grammar of English, but what is actually the task. And there's a bunch of pre-trained models that you can download that are available. You've heard about some, probably lots of people have mentioned these, T5, GPT-3, BART, et cetera. And then there's others that are trained with code, like Codex. And these, there's a few ways we can use these pre-trained language models. They're great because then you don't need as much in-domain training data, which for dialogue is hard to get. And so one way you can do it is use the small amount of data you have in fine tuning with the pre-trained language models. But another thing you can do is what's known as in context learning. So you don't do any more training, you just provide some examples in the prefix. And I'll get to that in some of my examples. Okay, so just to put this in a little picture, what I'm doing is I'm taking the context in terms of the conversational context and the user turn and making it one long sequence. That's going to be my prefix that goes into my neural language model, which is then going to generate the response. Now, the whole point of the talk is conversation context. So what do I mean by conversation context? Well, that first thing that everybody thinks about is the conversation history, everything that's been said so far. In this community, people think about knowledge grounding, super important. And then on top of that, about participant roles and goals. So let's take those one at a time. With conversation history, we have with conversation history, we have a person talking to the language model, the system responds, and then we're going to take that response and copy it, those two turns, utterances, and you're going to copy it into the history, put it into the, tack it on, and then the new utterance will come out, and then the language model will use that whole sequence to generate the next response. Okay, and this is great if you want to do a mindless conversation and chit chat, and if you don't care how accurate it is. But if you want to actually, oops, can I get, there. But if you actually want to have a more meaningful and useful conversation, you need to have, it's great to have grounding. And so, and speaking to the choir here, this is really important. And one of the frameworks for grounded knowledge is unstructured grounded knowledge, where you have a whole bunch of documents. And I'm coming from the perspective that probably that unstructured knowledge, if it's really useful, is going to be large. And so you're going to have to select knowledge from that to effectively be able to put it in this language model prompt, because that can't be huge. So you're going to encode that big history and encode documents and pull that together to select what might be the most relevant pieces of knowledge to incorporate when you're doing the response. And this is exactly the sort of thing that was worked on last year in DialDoc, and it was a super great workshop, and I'm happy that the tasks are continuing. Okay, now another type of knowledge, as Michelle was mentioning, is structured knowledge. And in this case, retrieval is basically a database query. And this is a sort of thing that people have been working on for quite a long time. And particularly the strategy is to do dialogue state tracking. So you're going to keep track of the types of information a user is requesting in a dialogue state. And based on the new things, the changes to that state that come in, you do a database query to get information that gets used in the response. And so here, what we're going to do with our language model is instead of, so we're going to tack on the ontology to the prefix in addition to the whole history, use that language model to generate a dialogue state. Then you can use that dialogue state again in another language model to generate the response. One could skip the dialogue state and just generate the response directly, but it turns out that having the dialogue state is actually quite useful when we get into more complicated responses, more complicated tasks. And the reason for this, the reason that this is so important actually, is because if you go back to this slide, you can see that if it's a complex dialogue where you're doing more than asking a couple questions, then the length of the history can get long. And if the ontology is complex, then the length of that can sort of grow. And so this prefix that goes into the language model gets longer and longer and longer. So the challenge is, if I'm using an RNN, then you're going to forget the past. If I'm using a transformer, as things get longer and longer, you have quadratic complexity. So that means I have to use big giant language models that, yes, they're getting bigger, but it gets more expensive, and maybe we can do a better job. Plus, as that history gets longer and longer, some of the part information in that history could be really a distraction. So for example, not all of those words are equal. Maybe the more recent ones are more important, but you don't know where the boundary is. There could be a topic shift, there could be corrections. So keeping that full long word sequence is not really an efficient representation of the relevant context for response. What we really need is this concept of shared knowledge. You know, an efficient representation of what both people have said and know. For structured knowledge, that shared knowledge is just the dialogue state. So what we can do is take that dialogue state, ST, that we've predicted, and instead of copying back all of the turns, I just copy the last dialogue state. And then I have the last dialogue state. So I have all this history here in a full dialogue context. I compress all of the past history into a dialogue state context. And then I know, what did the system ask last? What did the user respond? Put that into the language model with the ontology again to predict the dialogue state, to predict the response. And so what's nice about this is if you condense the whole history into a dialogue state, the length can grow as more things get put into the dialogue state, but it's not growing nearly as fast as all the words that you said. Moreover, it has more, so the alternative is you could truncate the history, but by having this dialogue state that's just keeping track of things, it's going to have more information than a truncated history. And further, if somebody resets the context, then that gets captured in the dialogue state without trying to figure out at what point in time the topic changed or knowledge was corrected. So it's a very efficient representation, and it does in fact lead to better performance in the language model dialogue state prediction task. But what's actually really cool about being able to shrink the size is it now gives us an opportunity to do a different type of learning. It gives us an opportunity to explore this idea of in-context learning. So in context learning, we're not going to retrain. We're not going to do any fine tuning. We're going to say, okay, my language model is really powerful. It's learned about a lot of different tasks. So I just need to give it examples that describe the task and the task schema, because it's structured knowledge. And then those examples in the prefix or the prompt, together with the current dialogue turns, will lead to getting a good output. On top of that, and the fact that I've shortened the context means that I can have multiple examples in this prompt. Now, the fact that this is structured data for this task-oriented case means that I can use that. What I really want to do for the output of the dialogue state tracking, what I really want to do is actually issue an SQL query to the database to get the data I want. So what that means is I could put out, instead of putting out the whole dialogue state, I could put out the SQL query, sort of separately keep track of that dialogue state using the SQL query. But once I'm putting out the SQL query, I can use one of those language models that's trained with code and get very good performance on going directly after the task that I want to go after, which is getting the knowledge that the person requested. And so this allows me to do in-context learning and actually gives really good performance without any language model retraining in few shot settings. Okay, now what about, I said I'm arguing for this idea of using the dialogue state instead of using the whole history. What do I do if it's knowledge grounded with documents? Okay, so it's easy to think about the dialogue state when you've got these, Hotel 4 stars, Hotel Area West. That seems pretty easy to represent. What about the dialogue state when somebody's talking about documents? Well, that's a real open problem, but I think you can still do it with language by doing query rewrites to summarize as a way of summarizing the history, and doing knowledge summaries as a way of summarizing the information that's been provided. Okay, now I'm going to do a role reversal. It's similar to what Michelle talked about when saying, okay, you can talk about a document, or you could have a dialogue that generates a document. I'm going to say a lot of the work is looking at humans doing information seeking, but there are a whole lot of applications where you want the agent to do the information seeking from the human. So surveys, like polling, problem reporting. So for example, one of the earliest spoken dialogue systems was reporting lost luggage. You report power outages, my internet's down, but also there's problem solving, help desk, call centers. So there are a lot of these examples where to solve the problem, the agent needs to find out information from the user. What's wrong? Is it doing this? Okay, now is it doing that? And that's that's sort of like the slot filling reversed, right? You want to figure out what in the slot filling stuff, you want to figure out what the user wants. In the problem solving, you need to fill in some slots in order to find the right solution. Unfortunately, the human answers don't always fit nicely into the slots. If you look at any real call center data, some people blabber on, and some people give you direct answers. Some people aren't clear on the concept and need to disambiguate some things. And so that concept of dialogue state would be, doesn't turn around quite so nicely as in that task-oriented dialogue case, the slot filling case. On the other hand, typically there's a lot of structure to these problem solving dialogues. And agents have these, steps and FAQs of things that they can do to solve things. And that structure, which is in the form of subtasks, is learnable from human-human dialogues. So the idea, we've been playing around with call center dialogues, which I can't give you examples of because of private information, but also simple other types of dialogues that are in shared tasks. You take the participant turns or utterances, and you can encode them into embeddings. We know how to do that. So you have a sequence of turn level embeddings, and we can take basic hidden Markov model learning technology, heaven forbid hidden Markov models, but yes, they still can be useful because they do describe this nice task-oriented structure. And so if you can start from a simple begin, middle, end hidden Markov model and learn the different sequences and alternative path structures that people go through in problem solving, which is basically iteratively partitioning this the sequence space into different states and growing the model to learn the details of the task. And then how do we do this in language? You can represent the current state with a summary for use in that language model. Okay, just to give you an example, this actually allows you to learn interesting things. This is a small task. You learn more interesting things on more interesting call center data, but this is a Craigslist negotiation dialogue set. And you learn, of course, you start with a greeting. You close with somebody accepting an offer. In the beginning, after you do your greeting and establish what's going on, the first thing that happens is the buyer wants to know the condition of the item they're buying. And of course, it's always in good condition. Then they make an initial offer, which is always low. But maybe not. And if it's not low, then you've got a quick sale. But then there's a couple other different pathways you could go through it. It turns out you got a couple different types of scenarios. One where the buyer keeps making the offer, probably they want to sell more, they want to buy more than they really like this item. And the seller is really in control and setting the minimum. And then the other path where the seller keeps making offers, they want to really get rid of it. And finally you get the final offer, the offer is accepted and you're done. And so this simple method of learning allows you to learn some interesting structure. Now this is obvious structure because this is a relatively simple task, but in other structures, in call center tasks, it can be much more complex and interesting. And you can learn what is effective strategies. Okay, now there's just to sort of wrap up my last bit, there's really two types of knowledge. We've got the knowledge that's our external data sources, documents, databases, what the user knows about their knowledge sources, what they have access to. But we also have this idea of knowledge about the participants. And that could be user preferences, user limitations. Oh dear, hold on, I'm sorry. Okay, sorry, cat problem. So there could be preferences, limitations, the user uncertainty, and all of these things are useful for personalizing the responses, narrowing down the information sources, and correcting errors, which is important in dialogue. Okay, so now what we have is the context is history, knowledge, and roles, speaker roles, and speaker state. That speaker state could be global knowledge, and that could be provided with metadata, explicit queries, implicit tracking. And we know from work with looking at user preferences and information seeking that tracking that user state improves the ranking of options to provide to the user. Like the knowledge identification problem, this doesn't fit perfectly in the language model paradigm. We're trying to pull out some extra information. So the user state is not language. And so that's kind of okay. It basically is just saying that there's more that we can bring to this problem than just a big long sequence. The other aspect is detecting and correcting mismatches and shared knowledge. Current systems don't do this very well because most shared tasks don't support it for a couple reasons. One, because of the way the data is collected. The other, because of the huge difficulty of actually evaluating these things. Okay, so just to conclude, my key takeaways are, first of all, that goal-oriented conversational AI needs context that is not just the sequence of words spoken, both the grounding in external knowledge, but also participant info. For complex tasks, we can represent history with the dialogue state. If it's an information-seeking context, and structured data, that could be just simply slot filling, which you can represent with a sequence of words. If it's unstructured data, we can summarize and rewrite the context. For problem-solving context, we can automatically learn these subtask states, which again could be described in terms of words via summarization. For user differences, it can be useful to have a speaker state, but once you start introducing some of these things, you are really bringing in some extra stuff to the language model and extra stuff to the context. And maybe language models can solve a lot of things with a little help and a little tweaks here and there. So just to end, I think this whole idea of looking at context has a lot of different ways it can go. Conversation history gets much more complicated when you have multiple people. The discussions are not strictly sequential. Knowledge grounding, as a lot of people here know very well, knowledge can be multimodal and both structured and unstructured, and that complicates the grounding. And lastly, once you start with a lot of the things that we think about doing, the participants are cooperative in trying to solve problems, but you could have adversarial actors. And of course, finally, the elephant in the room is test level evaluation. Okay, with that, I will stop.